okay? So all we need to do is plug in the value of x into the equation and we will get an answer. When we plug in x equals -1, this first one, what are we gonna get? What is 3 times -1 squared? Nicole?
3.
Yes, very good. Why is it positive 3?
-1 multiplied together is 1, and then 1 times 3.
Very good. This is the same as 3 times 1, which is just 3. If you got -3, okay, I'm glad that you accounted for the negative, but remember, when you square something that's negative, that would be 2 negative things multiplied together, which would give you a positive in the end. Alan, what's up? Yeah, that's fine. Okay. All right, our second one. So when x was -1, we got positive 3. When y was, when x was 0, what are we going to get? Y equals 3 times 0 squared. Tessa? Just 0, okay? Anything times 0 is just 0. So 0 times 0 is 0, and then you multiply that by 3, you still get 0. Okay. So this one was 0. What about if x was 1? Ashton, what'd you get? It would just be 3. Very good. So we have 2 y values of 3. Do you guys see that? We have when x is -1, y is 3. And when x is +1, y is 3. Let's see. Moving on. So let's try at 2. If y equals 3 times 2 squared, what are we going to get? Well, this is technically 3 times 2 times 2. Tessa, what'd you get? Not 9. 12, yeah. Okay? Because 2 squared is 4, and you take 3 and you multiply by 4, and you get 12. So at 2, y is 12. And our last one at 3. So y, oopsie daisies. Y equals 3 times 3 squared. Ashton?
It would be 3 parentheses 3 times 3.
3 times 9. And then? 27, perfect. All right, so we filled in our chart. We're going to be doing a lot of this in this lesson, okay? Because we need to see exactly what the y equals x squared graph looks like. What we call that is a quadratic, all right? Also, those of you on Zoom, you guys are very lucky. There's no AC in the entire building, so we are all sweating and very uncomfortable and unhappy. So be thankful that you have AC in your home.
It makes me feel better. We don't have the greatest AC here, so it's really just a giant fan right next to me.
You know, that does actually comfort me a little bit. Thank you, Carlos. We're all in this together. We're not alone.
Yeah.
All right, so if you see me like slowing down today, it's because it's very hot in here, okay? All right, so any questions on the warm-up? Any questions on? Our objective in this lesson is to graph quadratic functions of the form y equals ax squared and y equals ax squared plus c. And it goes over the standard form of a quadratic function, which we already talked about, where it's ax squared plus bx plus c. And then we've got some examples, and then we are going to talk about the parent function, which is y equals x squared. What we're learning today is we're going to be dealing with anything that involves x squared, but we're not factoring anymore, right? We're not factoring it, we're just going to graph it, okay? And the two types that we're going to learn today are y equals 3x squared and y equals x squared plus a number, okay? We are not going to be dealing with today this one right here where we have a middle term, okay? We're only gonna be dealing with one term or two terms. All right? And that second term will always just be a number, okay? So let's take a look at this example, okay? I don't want you copying down anything right now. I just want you listening, okay? So in this graph, all right, this is what we call the parent function, y equals x squared, right? And what we call it is it's a hyperbola, okay? It's a quadratic function. And as our x values increase, okay? So at 0, 0, we have a point here. As we move to the right with our x values, our y values increase, but they also are increasing and increasing even more. Do you notice how it keeps getting steeper and steeper and steeper? Do you guys see that? Like it started kind of like, okay, we're going from 0 to 1. Now we're going from 1 to 4. And now we're going from 4 to 9. So as you increase, you're also getting steeper and steeper and steeper. That's why this is a curve. It's not a line, right? Because if this was a line, that would mean that you're increasing by the same amount every single time. We're used to seeing these lines. Now we're dealing with a curve, okay? Also, in the negative direction, because this is x squared, okay? Just like we did in our warm-up, right? All of the negative values for x, so y equals -1 squared, y equals -2 squared, and y equals -3 squared. These all turn into positives, right? Because we're multiplying two negatives by themselves, so this becomes 1, this becomes 4, and this becomes 9. So our graph, notice, it never goes negative. There's never y values that are negative, right? So whenever that's the case, right, we call this point down here our vertex and we label it a minimum, okay? It's a minimum because it's the smallest y value, right? It's the smallest value on the graph is 0. Everything else in the y direction is going to be bigger. Do we have a maximum value, guys? I see some people shaking their heads. Why don't we have a maximum value? Nicole?
Because it can go like up to infinity.
Very good. These two arrows means that it's going to go infinitely upwards. So there's no max value. When y equals x squared, there's no maximum. There's only a minimum, okay? So right now, do the best to your abilities. I need you to copy down y equals x squared, put a little graph if you have graph paper, and plot this graph, okay? You don't have to add what's in blue. But whatever's in pink and red, I need you guys copying down. And then put that little portion, vertex is either a maximum or a minimum on the left side, okay? Negative x. Y equals negative x. So every single positive value for y that we had is now negative. So what we did was we took the graph, which was facing upwards, and now we changed everything to negative. So now it's completely flipped on the other side and it's going down. Okay, so if we look at this graph and we're like, what's the minimum value? Do we have a minimum value? We don't. Why don't we have a minimum value, Victoria? Yeah, it's going down. So it's going down forever. We're never going to hit rock bottom. Okay? It's just going to keep going down, 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 down. Do we have a maximum value? Do we have a maximum value? Nicole?
Yes.
What is it?
0, 0.
Very good. It's what we call the vertex, okay? So it's this point right here. Its point is 0, 0, and this is our vertex. And yes, it is a maximum. Okay, copy down this example. Make sure you label it y equals -x squared. Let's do, you're not going to copy any of this down, but let's do just a few problems together, okay? Take a look at this graph down here. We need to find out where the vertex is, and we need to determine if it's a maximum or it's a minimum. Remember, don't copy this down. Okay, so Do we have a vertex? That's where our graph changes direction. Alan?
No, I don't get
Nicole?
Is the vertex the 0.0,
Uh,
0.1?
Ooh, close. This would be 0, comma 1. Rioni, where is it?
I have to actually make both of that.
Yeah, you can go to the bathroom. Tessa?
So it's going to be 0.3.
0, comma 3, okay? This is what we call our vertex. It's where the graph changes direction. It's either a maximum or a minimum. Vertex, and this one is at 0, comma 3. Is it a maximum or a minimum of the graph? Elijah?
Maximum.
Very good. It's a maximum. Why?
Because it's like the highest point.
Very good. It's the highest point. If this was a roller coaster, right? This would be the highest point on the roller coaster, right? If you had people like in here, you would be going up, 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 and then you would start to decline once you get to this point. It is our maximum point on the graph, okay? Take a look at this one. First, let's find out where the vertex is, and then let's determine whether it's a maximum or a minimum. Where's the vertex here, Alan?
-1, -1, -1.
1, -1. Why is it 1, -1 and not -1, comma 1? Yes, your x value or your x coordinate always comes first. So this is our vertex at 1, comma -1. And someone tell me whether it's a maximum or a minimum. Ashton?
It's a minimum
Why?
because if it's like down.
Very good, okay? It is a minimum because our graph, that is the smallest point or the smallest value of y in our graph, okay? It's a minimum. There's no maximum because those arrows point upwards, so it's gonna keep on going up and up and up forever. Alan, what's up?
So the maximum is the highest point and the minimum is the lowest.
Correct. The maximum is the highest point and the minimum is the lowest. Very good. Okay. One more thing, guys. When we write, hold on. Maybe I have to go to the next. There we go. Okay. We're going to graph the function y equals ax squared, where our a is 1/3. Okay. So we're still not adding anything, but we're changing what a is. Let's make a 1/3. So let's create a chart. Here's our y values. Here's our x. And let's plug in for x. Hold on, let me see if I can move this. Oh, that was not good. Never mind. Let's plug in for x, -2, or I'm sorry, -3,
Can we write this part down?
-1, yes, 0, 1, and 3. Okay, so let's say we had x equals -3. So our equation is y equals 1/3 times -3 squared. I'll give you guys a second to copy this down, and then we'll talk about it.
Why don't you pick numbers for the x?
Yeah. Why did I skip 2?
Yeah.
Because I wanna get clean fractions. So you notice how it's 1/3, right? If I picked -2, I would get like something that's not divisible by 3. So I would keep my fraction. I wanted to pick 3 just so I would get an even number. Or a number that's not a fraction. Ashton?
You copy down the graph too?
We'll do the graph at the very end. Okay. Okay, so if we have 1/3 times -3 squared, what is that going to become? Tessa?
Is it going to be 3?
Ah, very good. Why?
Okay, so like, when I did 1 divided by 3 is 0.33, infinity times 3 times 3
Okay.
Three.
So this is -3 times -3, which you're saying is 9, right?
Yeah.
So this is 1/3 times -3 times -3 is +9. And then Tessa was like, well, 9 divided by 3 is just 3. Okay? Or you can actually multiply it out and it would be 1/3 times 9/1, which would give us 9/3. I'm running into the graph. I don't want to do that. Sorry. I'm going to bring this down here. It's 1/3 times 9/1, which is 9/3, which is just 3. So when x is -3, y is 3. When x is -1, let's check it out. If x is -1, we've got y equals 1/3 times -1 squared. What do we get when x is -1? Ashton?
So first what I did was I did the 2 and the -1.
Okay.
And that's positive.
It's just 1/3. Awesome. So we got 1/3 for this one. Let's put that in our chart. So 1/3. What would happen if we plugged in x equals 0? Y equals 1/3 times 0 squared. Tessa? Just going to be 0. Anything times 0 will just give us 0. So this is 0, 0. Let's plug in x equals 1. Y equals... Okay, so y equals 1/3 times, and we're plugging in x is 1. And we're squaring it. This is the same as 1/3 times 1 times 1, which is 1/3. So at x equals 1, y is 1/3. And our very last one at x equals 3. So y equals 1/3 times 3 squared. What do we get here? Tessa?
Don't you get three?
Yep, you just get 3 because this is 1/3 times 9, and 9 divided by 3 is just 3. Just like we did for the red one. So this is 3. Okay, now that we've created our chart, let's go ahead and plot this, okay? Let's plot this. So we've got at -3 in the x direction, our first point is y equals 3. So let's go -3 in the x direction and then up 3 in the y direction. So right here. I want you guys plotting this with me. So if you don't have a graph paper, just do your best on line paper. So here's our first point.
Here, Phil?
Yeah,
How does loading room?
I know.
Oh,
Okay. At x equals -1, y is 1/3. So we're going to go to the left 1 at x equals -1, so right here. And we're going to go up 1/3, so right about here. Just above that, above the axis, right here. Our next point is at x equals 0. y equals 0. That is the origin. That's 0, 0. That's this point right in the middle of our graph. And let me do these points in red so we can see them. There we go. That's a little bit better. Okay, on the other side, we've got x equals 1, y equals 1/3. So let's go to the right 1 unit and then up 1/3. So it looks like this. And the same thing for x equals 3. At x equals 3, we have y equals 3. So this is our last point. And then to the best of our abilities, we're going to draw this graph using 2 curves. Our first curve is going to look like this. And our second curve is going to look like this. Let's compare this to our parent function that looks like this. What's different when comparing the red function to the green one? Because they're both at the vertex 0, 0, but look. This one was y equals 1/3 x squared. How does that compare to the regular y equals x squared, the green one? What's different about them? Anyone? What do you think, Janessa? What's that?
The green one's longer.
Yeah, the green one's longer. The red one's wider, right? So whenever you're taking a fraction, right, as your a, this is going to make your graph wider, okay? And if you had not a fraction, so like a number bigger than 1, it would make your graph skinnier, okay? So whenever you're taking a number that is less than 1, it's going to make your graph wider, okay? This is when your a is less than 1. If your a is greater than 1, it's going to make your graph skinnier. So instead of compared to the green one, if a was less than 1, it would look like this, okay? This is when a is greater than 1. It's going to be skinnier. All right, I know this is a lot, okay? This is where we're going to stop for today. Okay, and then another thing that we're going to talk about in this lesson is something called domain and range. So domain are what can the values of x be? And how we write the domain is we look and we see, okay, well, our x values, there's no restriction on them. They could be any value in the entire number line, right? Because our arrows are extending in this direction and this direction. That means that we could pick x to be 10, we could pick x to be -10, we could pick x to be -100, -1,000. It does not matter. So what we do is we write that our domain is -infinity to +infinity, okay? And this is what we call interval notation. So we're setting up an interval for all the values of x that x could potentially be, okay? And we're gonna do the same thing for y. So if we look at y, the smallest value of y is this one down here at 0. Y cannot be negative in this example. So what we do is we start our range from 0, okay? Notice how it's not negative infinity, and y can be anything over 0. So y continues up, the arrows are pointing up, so y can be any value above 0. So we say 0, it goes all the way from 0 to infinity, okay? The next one that we're going to do is y equals negative 3x squared. And as I said before, since that number in front of the x squared is greater than 1, it's going to look like the blue skinniest hyperbola, okay? It's going to be very, very skinny, and it's going to rise really, really fast. So let's check it out. Let's make our chart, x and y, and let's plug in for values of x. Let's start with x is negative 1. Then we'll move on to 0, 1, 2, and let's do negative 2 as well, okay? So if we plug those in, let's see what we get. All right, so check it out. Let's plug in negative 1. What do we get? So x is negative 1. We get y equals negative 3 times negative 1 squared. Make sure when you're plugging in for that variable, you include those parentheses. So once we have our parentheses, we're just going to square negative 1, and we get y equals negative 3 times negative 1 times negative 1, okay? So we wrote out the negative 1 twice. If you multiply 3 numbers together, 2 of them are going to cancel to become a positive, but you're still going to have that third negative. So our answer here is negative 3. So y equals negative 3. Okie doke, so we found for y, we got negative 3. Beautiful. So we're going to plug that into our chart. There it goes. And now we're going to plug in x equals 0. So y equals negative 3 times 0 squared. So when we plug in that 0, the most important part, as I said like a million times by now, is to make sure that whenever you enter it, that you put parentheses around the value that you're putting in. So if x is 0, you put parentheses around it. We square it, we get negative 3 times 0, which, yes, all of you already guessed it. It is just 0, okay? So we get that 0, we plug that in. So we know 0, 0 is a point. Let's plug in x equals 1. Y equals negative 3 times 1 squared equals. So at 1, this is just going to be 1 times negative 3, so just negative 3. So at 1, we also got negative 3. At 2, let's see what we get. Y equals negative 3 times 2 squared. This is going to be negative 3 times 2 times 2. Because remember, squaring something means you multiply it by itself 2 times. So this is going to be negative 6 times 2, which is negative 12. So we put in the negative 12. And then if we do negative 2 squared, we get y equals negative 3 times negative 2 squared, which is going to be negative 3 times negative 2 times negative 2, which is also negative 12. So we found all of the values that we need. Now we can go ahead and graph it and see what it looks like. Okay, so at x equals negative 1, y was negative 3. So we're going to go to in the x direction, negative 1, and then down 3 units in the y direction to negative 3. This is where they meet. This is where our point goes. Our next coordinate was 0, 0. So 0, 0 is the origin right here. Our next coordinate is 1, negative 3. So to the right 1 in the x direction, and then down 3 units. So here's our next coordinate. And then we've got at 2, we put negative 12, so 2, and then we're going to go down 12 units, so all the way down here. And then also at negative 2, our coordinate was negative 12. So look, just like we thought, guys, this graph, when we multiplied the x squared by negative 3, it became super, super skinny, okay? So remember, when that value in front of your x squared is bigger than 1, see how this 3 is bigger than 1? You don't necessarily care about the negative because that's just going to change how it's opening up. But the number portion, the 3, since it's bigger than 1, it makes your graph skinny. Now when we did 1/3, it made our graph nice and kind of like wide, kind of fat, okay? But in this one, it made it nice and skinny, nice and narrow, so it changes it in that way, okay? Now let's go ahead and find the domain and range. So the domain is whatever the x values can be. And as you can see, these arrows are pointing down, but they also point in this direction and in this direction, because you can pick any values for x to plug in. So once we know that, our x values can be negative infinity to infinity. All right, and now the range is going to be whatever the y values can be, okay? The y values, as you can see from the graph, they can't go bigger than 0. So 0 is our maximum, okay? So 0 is going to be the maximum on this side. And then our values go all the way down to negative infinity, because you see how the y, like the arrows are pointing down? They're going to go all the way to negative infinity. So that's our range. Okay, and the last thing that we're going to look at, guys, is we're going to look at when we shift a graph. So if you have y equals ax plus c, that means this c is an extra number that's being added to your x squared term. So for example, all these include 2x squared plus, or 2x squared. The first one has a plus 3, and that means that we shift the graph up 3 units. So your vertex is no longer going to be at 0, 0. It's going to be 3 units up. So if we go 1, 2, 3 units up, our vertex will be right here. And we can underline this one, make this the blue graph, and then 2x squared plus 3. We're just going to eyeball it. We're not going to plot all of the points. Looks something like that. Okay? Now, if our graph was 2x squared, no shift at all, remember, that's going to be at 0, 0. So right here, boom, and boom. More of a curve, if you can. Okay, and then the last one, y equals 2x squared minus 3. That's going to be a shift 3 units down. 1, 2, 3. So here is our vertex now. Boom, and boom. Now, if you guys were to plot all of the points, you would see the exact same thing. You would be like, oh, okay, I see that my graph shifted 3 units down. But it's much easier to recognize it based on the equation that they give you. So if you're able to see y equals x squared plus 3, you're like, oh, this is just the regular hyperbola shifted 3 units up. And the more we do these examples, the better we'll be at them. All right, so that's the end of the notes. Go ahead and start on your homework.